So mole conversions, that's your homework. Just, it's 4 pages. It's like 75 problems.
Oh my God.
You can get time to do it. Now, what I would like to do first, let's just do like a really basic example here. So let's say we've got 3.8 grams of carbon, and the problem says convert that to moles of carbon. All right, that's what it says. Now, to do this conversion, it's relatively straightforward. It's something that I think you could do without much supplemental help if I just showed you, but just in case this is a struggle, we have this chart here. Now, this chart will sort of act as like a guide to you to give you like an idea of what to do if you're not sure. Before we do that though, let's just set up our problem like you usually would. You do 3.8 grams of carbon. And you set it up. You put grams of carbon down there, because remember, whatever you write here, you put down there. That's just how it works. You should be trained for sure to do that now. Now, in this case, we are starting at grams and we are converting to moles. You're going grams to moles. That means we would divide by the periodic table molar mass. That's what this says. So this chart, it shows you what to do. You follow it, mass to moles, divide by the molar mass. Okay? That's how it works. That's why this chart is helpful, because it tells you what to do if you're not sure. Now, our goal here is to get to moles of carbon, so you put it on top, and yes, I will always be abbreviating MOL, for moles. Now, in terms of what we're going to write in, we're dividing by the molar mass, and we know that 1 mole of carbon is equal to a certain mass, molar mass. So what are we going to write in here? 12.01. So you put 12.01 grams is equal to 1 mole. So remember, when we do this, you have 12.01 grams, 1 mole. That's how it works. 1 mole of an element is equal to its molar mass. So you do that, then you do some math, cancel your stuff out, and you're going to end up with whatever it is you get. In this case, it'll be 3.8 divided by 12.01. So you get that. I'm going to go around to 0.32. Your labels would be moles of carbon. If you were to leave out moles or carbon, it would not be correct. All right, got to have both. Does that bring up questions? Yeah.
What if it was like,
What if it was like,
like times
what if,
10 to like the 23rd for like.
we're gonna do 2 with those. Like, so first, if this number, whatever this number is, it doesn't change anything. Like the first number, whatever you're given, that doesn't matter. It can be any number. But like the second one, it'll depend. Like if you're going mass to moles, like we are, mass to moles, you always have to use the molar mass, according to the periodic table, because you're converting from mass to moles, your units have to cancel. That's why units are important. However, if we were going from particles or molecules to moles, then we would use the, that number. All right, which we'll get to. I'll do 2 examples of that. Yeah. Yeah. We'd multiply. Yep, I'm going to show you that next. I'm going to do 4 examples, 1 for each, way. So next example, let's say this one. Let's say we've got 2.9 moles of aluminum oxide, and we want to convert that to mass in grams. Now, you set it up exactly the same. Before I like to do anything, I just want to write this out and always set up my problem so that you have some idea of, what you're doing. You should be able to get to this point without even thinking. Just, write down your thing here, copy the units down there. The next step, you got moles of Al2O3. You want to go now from moles back to mass. To do that, you will multiply by the molar mass, the periodic table. So to do that, you will multiply. Now, what are we using? Molar mass. So that's going to go on top. Grams of Al2O3. The other way, if you don't want to use this chart at all, is simply think about it like this. Your units are going to cancel here. Your goal is to get to this, so you put it on top. The chart and the cancellation of units, they work together, sort of help you out to make sure that you're going to get this in.
So you try to find
Yeah. So to do this now, there is no way to look up aluminum oxide's not on here, no matter how hard you look. But there's aluminum, there's oxygen. You add them up like we just did on this worksheet. You look at it, you add them up, you'll be fine. So to do that, you've got aluminum. You've got 2 of them. Aluminum is 26.98. And you do not need to show this part of the work, just so you know. I'm just doing this to make sure you see it, but you do not have to show this part of the work in your homework. Oxygen is 16 off the periodic table, and in case you're wondering where those numbers are coming from, you add it up, you get 53.96 plus 48, 101.96. Questions on that? How that happened? Why that went there? Anything? Yeah.
So is that just is this just continuation of what we did yesterday?
Yes. So like the thing we did yesterday, where we found the molar masses, now that's just part of this problem. Like you just have to do it to solve the problem. Yeah.
So when you find the molar mass, then the mole, that one, is it always 1 underneath it?
Yeah, so the way it'll work, it'll always be 1 mole of something is equivalent to, whatever it is you're doing. Like how we said here, 1 mole of Cl2 is equal to 70.9 grams of Cl2. It's also equal to that. So it's always going to be one of these things is equal to 1 mole. Whatever your numbers might be. It'll be this is equal to 1 mole. Or, like on the other one, it'll be this is equal to 1 mole on top. All right? So yes, to answer your question, it's always going to be 1 for the moles. I know that's what you want to know. So anyway, you do the math here again. You get an answer. What do you get? 295.68 grams. So the way you do this, you multiply 2.9 times 101.96. That's what I got. Questions? All right, let's do the examples now where we convert from particles to moles and moles to particles. Or does that bring up questions? All right. So next, let's do this. Let's say we've got 7.8 moles of sodium, and we're going to convert that to atoms of sodium. This is annoying how it doesn't focus. Like, this camera just lacks in function.
I don't think it's working.
You think? Wait. Oh. Whatever, good enough. Who needs high definition in 2016? Anyway, so we've got 7.8 moles of sodium. You got atoms of sodium. Now, in this case, atom is a particle. So the way it'll work, an atom is a particle. So you are going to be converting between moles and particles. And this one is easier, in my opinion, because you use the same number every time, regardless of the element or compound you start with. You are always using 6.02 times 10 to the 23rd. Doesn't matter. You just use that number. So what I mean by that, we're going moles to atoms. So if you follow, you multiply by Avogadro's number. So you multiply by Avogadro's number. Yep, so you set it up. 7.8 moles of sodium. Moles of sodium goes on the bottom. Our goal Atoms of sodium goes on top. Now, as I said, you are multiplying by Avogadro's number, and if you think about it, it also makes sense according to our units. As we said, 1 mole of anything, regardless of what it is. That is the most ridiculous bell, I swear. 1 mole of anything is equal to 6.02 times 10 to the 23rd. So, put it in there. There's going to be some kid watching this video, and they're going to be just like chilling, and the bell's going to ring, and they're going to be like, it's going to scare them. Anyway, that'll be Marty tonight when he's watching the video. We missed it from Quiz Bowl. Anyway, so you do 7.8 times 6.02 times 10 to the 23rd. You cancel out your units. You know, make sure you cancel everything out.
It's like show and cancel.
I would prefer it actually if you did cross your stuff off. Just because then it like leaves you with no doubt as to what your actual units are. I mean, I found that helps. Hello, annoying child. So you do that. You got. I would round this to 4.7 times 10 to the 24th atoms of sodium. So you just do 7.8 times 6.02, you know, times 10 to the 23rd, and that gives you the answer. That's how you do it. Just make sure when you type it in, you know, I mean, you don't need to use parentheses on top, but I like to always do that so that when you divide, you remember. It just always helps to put these quantities in parentheses so that you don't goof up division. You'll see on the next one. Any other questions? All right, remember, 5 examples. This is number 4. Then there's one more. The last one's the hard one, but whatever. You're going to have a lot of time to work. We're getting through this like 4 times as fast as the other classes because you're paying attention. H2O, 2 moles of H2O. So, what is the difference between this problem and this problem?
What's from the molecular?
Yeah, so they're, you know, it's obviously going from particles to moles. So it's different in that it's going particles up to moles as opposed to down. But also look at the units. Notice atoms, molecules. Now, the unit is different, but that does not change anything. Not a thing. Doesn't change a thing. Because atoms and molecules are both particles. They are both representative particles. They're just particles. They don't change anything. So you still use Avogadro's number. Not a big deal. So you set it up. 6.8 times 10 to the 19th molecules of H2O. Now I abbreviate molecules MOLEC. You can't abbreviate anything with an M because M means something else, and little lower m, lowercase m means something else. You know, you just gotta abbreviate it like that. Your goal goes on top, and if you think about it, look at your chart. Molecules, 2 moles, you divide by Avogadro's number. So 1 mole, 6.02 times 10 to the 23rd. What did you say? 10 to the 19th. Divided by, make sure you divide by parentheses when you do this. Make sure you use parentheses. So you should get that. Now, if you don't use parentheses, you will get a number that would be like something times 10 to the 42nd power, probably. If you get that, that means you didn't do it right and you didn't use parentheses. Remember that. when you divide, you must use parentheses. Otherwise, remember, it'll do divide by 6.02, stop, times 10 to the 23rd. So it would goof everything up. Question on this one? No? No, I got to do the fifth one. That's the hard one. No. All right. Yeah.
So put it inside the division.
I would really prefer it, yeah. You know, if it's like... How about do up to like 3 decimals after that, put in scientific notation. All right. Yeah.
Why do you do H2O with
Say it louder.
when you add the molar mass?
Why do I what?
Why do you add the molar mass?
Why didn't I?
Yeah.
Because, so why didn't I add the molar mass? Like, why did we not figure out the mass of H2O off the periodic table? Because when we're dealing with molecules, and we're going to moles, molecules to moles, it doesn't require the molar mass. Because all you're doing is converting between moles and, you know, particles. So all you're doing is using Avogadro's number. You are not in any way dealing with the molar mass. If we were dealing with grams, you would. But it's like, you know, it's like saying, all right, I need a dozen eggs. You just want to get 12 eggs. You don't care how much they weigh, do you? You know what I mean? It's the same thing if you want a dozen cars. You just want 12 of them. You don't care how much they weigh. That's the same deal here. We just want so many moles. We don't care how much it weighs. If you care about mass, then you do that, all right? So there's that. We'll do the last one now, and then we will be done. So let me record more. So now the last one. This is a 2-step problem now. So far you've noticed that you cannot convert directly, probably, from mass to particles. There just simply is no easy way to do this. So you have to do 2 steps. So let's do one, and we can stop. So we're going to convert between 3.8 grams of NO3. We're going to convert that to molecules of nitrate. So if you want me to. So molecules of nitrate. So grams all the way to molecules. Grams to moles to molecules. That's what we're doing. You set it up the same, 3.8 grams of NO3. Now, in this case, this is the first time where you don't write what, like, you do not just copy this down right here. This is not what we're going to do. We're going to have an intermediary step. So you do not copy molecules directly down there. Instead, you are going molecules to mass to moles. So you will divide by the periodic table mass, and moles will go right there. Now, 1 mole, dividing by that mass of nitrate, you got N, you got O, so it'll be 14.01 plus,
46.
yeah, no, 48,
Yeah, 48.
yeah. That gives you 62.01. That's because there's 1 N, there's 3 O's, that's where it comes from. So, that's your first step. Questions on first step?
Is there anything that would tell us it's a 2-step?
Well, yeah. So the way you would know it's 2 steps is because you'd look at this. You know, this is where the chart does come in handy initially, because you look and you're like, okay, I need to go from grams to molecules, and you think, is there a conversion that tells me directly grams to molecules? There's not, and you can tell also if you look at the chart, you got to go mass to moles to particles. Like, there is no, you know, direct route there. That's how you know. You actually need to, like, plot out your, like, course, and that's how you can tell. All right.
Are we not going to be using the volume?
We will. Oh yeah, we'll do volume in like 2 days or 3 days. So yeah, the volume will come into play in a couple days. So next, you copy moles of NO3 down here. So you copy that. And then you put your goal finally up there. So moles of NO3, molecules of NO3. Now, this makes sense because you're now at moles. You want to go to molecules. You multiply by Avogadro's number. So multiply by that number. So 6.02 times 10 to the 23rd, equivalent to 1 mole. Any questions on anything? Done. So you do that, you cancel everything, you get your molecules of NO3. As far as math goes, remember you multiply on top, divide by the bottom, you get that. We'll say 3.69 times 10 to the 22nd. There you go. So, does that bring up questions? Yeah.
If we know, if we know that we can do it, well, can we do it in one step?
What?
If you know that you're gonna end up with this, can you cross out the one and just have it in one step?
No. I'd really prefer it if you didn't. I know what you're saying. You just want to set this on top of this, right? I prefer you didn't. Because eventually,
They won't be ones.
yeah, they won't always be ones. I mean, it's okay. I know what you're saying. If that helps you, fine. But like for the work in the packet, do it this way. All right. But in real life. Any other questions? Okay.